Okay, is that working now? I hope so. Fun thing is, I have construction happening right below me, so we might hear some drilling in the background. But hey, this is the joy of working from home in this situation. Okay, my talk. Obvious title. It's actually really short. It's only one slide. I can do this. There. That's the whole talk. Okay, let's go into a little more detail though. I'll try and explain why you don't want to make users mad and what happens when you do. A little bit about me, since it didn't introduce me. I've been a kernel developer for way too long. I used to be a embedded developer before that. I maintain stable kernels. I have done a lot of user space work, but at the low level, I also maintain some user space packages. I will make fun of GNOME later, but let me tell you, I have been advisory board for them for many years, and I'm still a foundation member. And I've worked on lots and lots of different distros. So all this stuff comes down to a pretty simple thing. Who are you writing code for? Are you writing code for what type of, why are you doing this? Why, it depends on why you're doing this, depends on what you should do. So, very simple. If you're writing for yourself, then it's not a problem. You throw it over the wall, you have fun, you put it out there, publish it. You want other people to see the stuff, get a resume. Wonderful, no problem at all. Don't care about anything. Don't worry about it. But the problem is, if you write something that's useful, it will come back and bite you. SSLay and OpenSSL was infamously created because the developer wanted to learn C. And all the problems that happened with that. One of the forks of UDEV was because somebody wanted to learn C again and put it out there, and people start relying on it, and they have to maintain it and use it. So if you do this, just watch out, because it can happen. If you're writing code for others, which I think everybody here is, because we all want to write open source software, we want people to use it, then we have to care about the users. And we have to care about what they think, what they do, and how we react to them. And we have to think about them when we create the software, within reason. There's the infamous XKAD document of somebody's odd feature. A bug was the feature. Everything I say here is within reason, because there are always some users you can never please, no matter what. And those people you can safely ignore. So let's start out. What you do and how you act on creating code depends on who you are. And I'll break everything down into about 3 different groups here. Kernel developers. This audience is not kernel developers, but since I am one, I'll talk about what we've learned and how we've made mistakes and what we've learned from that, and how to apply it again to library developers and application developers, which is the primary audience here. So first off, kernel developers. Easy thing. We only have really one rule. And Linus gets mad at this whenever you see rants in the press or whatnot. This is when we break this rule. And the rule is we cannot break user space, and cannot break user space on purpose. Break it accidentally, we'll fix it, whatever. We break user space if nobody notices, that's fine, because we take advantage of things that when you don't notice, different functionalities or stuff, but you just can't break user space. And we make this rule, and other operating systems have this rule as well. It's a very solid rule, because we always want you to upgrade. And we want you to upgrade without worrying about it. We don't want you to feel scared if you see a new release and we say, hey, this fixes a bunch of problems. We don't want you to feel worried about taking that. And that's really, really important, especially with security. You want people to take all these fixes. You want people to be able to upgrade. You want them to also take advantage of the new features. And if you have them even hesitate about updating to your latest version because you've broken functionality for them, they won't. And that's not okay. Again, users, we've learned this the hard way. They will not update if they're afraid you're going to break it. And in the long time kernel past, we used to break things, and we now realize that is not what we should ever do. I'm going to have a few number of rules in this talk. They're not necessarily my rules, but I'll claim them for the choice of the talk. So the problem with never breaking user space is what you do when you need things to change. The trick is you just support everything until there are no users. Figuring out when there are and are not users is up to you. In the kernel, sometimes we know that, oh, there are no hardware of this type out there. We used to have an architecture where we knew there was only 2 machines in existence. One of them broke, and the other one we actually paid the developer to replace it because we didn't want to support that thing anymore. Other bits of hardware we ripped out of the kernel when we knew things weren't even being used anymore. We just ripped some code out from Intel, that a device that they know is not in the field, that nobody actually uses. That's fine. But otherwise, we have to keep supporting users. Because we made that contract. We made that contract that we gave them a functionality, we cannot remove it. But what we can do is we can evolve things over time so that nobody actually notices. We can move to different ways things happen. We can do different things, how stuff works, and we can provide new ways of doing things. And if we provide new ways of doing things, hopefully people will migrate over time. In reality, they don't. They stick to the old stuff, which is fine, but we can provide new ways. And this is how we constantly evolve and how we constantly move forward. And this is how you survive, because you have to change with the world, so you have to provide new functionality. A lot of people, I get this complaint a lot from a number of people who have been in the IT and the computer industry for a long time, saying, well, how is Linux succeeding? It's an old model. The old Unix POSIX model is obsolete. We shouldn't be doing this anymore. And the problem is, in one way, Linux supports that. They support your binaries from 20 years ago, from 25 years ago. You can still run really old BSD applications, you rebuild them and they work. Or you can run your application that was built 20 years ago and it still works. So people think Linux is stagnated. But in reality, we've created new functionalities right next to the old functionalities, and that you can do different things. You can take advantage of stuff. We have eBPF, which is taking over the world. It's a microkernel-like architecture. You can run user space programs on the kernel. You can do all this fancy stuff, proven that you can't lock up the kernel. Wonderful stuff. IOU ring is fast asynchronous IO in a different way that has ever been done before. And it's, again, sitting right next to the old POSIX model so that your old programs can work just fine, but new programs can take advantage of stuff and take advantage of speed increases. Of course, Linux now is a real-time operating system. It's been a real-time operating system for a while without a tree patch. Those changes are almost all merged. That's something people said could never possibly be done, but yet we did it right next to the existing operating system and nobody noticed. That's how you do it. You evolve and add new functionality without breaking anything. In order to do this, you have to create the trust that people can rely on. The kernel developers made this public promise 15 years ago, and we haven't broken it since. And that is how we're succeeding. Because if we break that trust, people will stop using us. And that's not okay. And we learned this really, really a hard way. When old development model, we used to have stable in the development trees, and the development tree would last a year, and then the development tree lasted 2 years, and then almost 3 years, and it turned into a nightmare. We broke things, we had to roll things back, we had to make things work again, we had huge, massive forks, we all were working on different things at different times, and it was a nightmare. Then after 2.6 came out, a long time ago, we said, we're never going to do this again, and we're all going to be stable. Every single release we do is stable. So we've been that way since 2003, and it's worked. And people rely on us, and we've done it. People said, this is something you can't really do. We kind of proved that you can do this. We have a release every 3 months. It's stable. It's maintained. We have long-term trees that people want to stick to those for various reasons for certain hardware or products. But it can be done. And so I recommend that the stable model, rolling releases, time-based stuff works. So we've figured it out the hard way. Other operating systems have done this before. Windows infamously maintains backward compatibility. OS X does not. And you see OS X developers getting very mad about that. So it's a trade-off. Depends on where you want your operating system to be used or not. Along those lines, this is a big reason. Because we can't force anybody to use Linux because it's free. You can use it if you want to or not, if it solves your problem. But we should never create and give you a reason to stop using it once you used it. Once you use it and rely on it, we don't want you to be bad about it. We don't want to make a breaking change that keeps you, that causes you to move away. And that's something really important. If you write software, you don't want to alienate people and cause them to go away, hopefully, if you like users. Okay, that's kernel development. I guess we'll do questions at the end. So I'll wait. This is going fast. This is fun. Let's talk about library developers. I know there's a number of library developers here, and this is the hardest job ever. I really, really feel sorry for you. Writing a library develop is hard. It's one of the hardest things to do. In the kernel, we're really lucky because we have internal APIs that we can evolve and change over time. Because they're inside the kernel, we don't have to worry about breaking that. once things go outside the kernel, I mean, that's all a library is. It's an outwardly facing API. It's impossible. And the main reason that it's impossible is you can never know if your API actually works until you have a lot of people using it. And by the time you have a lot of people using it, then you realize all the problems were with it, and then you can't change it. Getting it right the first time is almost impossible. It's hard. I don't know how you guys do it. It's a very difficult task. The few libraries I've had to write are horrible, and you learn over time. There's some good ideas on how to do libraries, but it's really difficult. Here's some good ideas. One thing is you can never break anything. If somebody starts using your library, you can't break it. That's just a flat out rule. You should not ever break that rule. Otherwise, you'll not use it. You won't have a user anymore. The only way you can fix things is by creating new ones. And when you create a new API, you can hope people move to that API, but you still gotta stick around and keep that old API. But in that API that you're creating, you need to be strict. You should not follow the Postal's law for APIs. It just does not work. We've seen it happen time and time again. If you accept things that are too that are out of bounds or out of scope from what you think you should be accepting, and then you try and change that later on, you will break real users. So you need to be very strict in the beginning. In the kernel, we learned this the hard way with system calls. We had extra fields and other sections of ioctls and such that we didn't care about. And then when we wanted to increase things or add a new feature or change something, we all of a sudden had to accept that those fields would be full of garbage. And we couldn't do that. So we now have a rule when we add new fields and new system calls that we have, if anything is reserved or anything is reserved for future use, we check it. And we check to make sure it's set to nothing. And otherwise, we will break in the future, and we'll have to create another system call. If you look, we number our system calls. If you have the 3rd and 4th version of them, we have a number of those over time. That's just how things grow. So don't follow Postal's law when you're creating an API. You cannot maintain it over time. Just trust me. Look at glibc. They know how to do this well as well. Slides. Oh, there we go. Rusty Russell is a kernel developer. Back in 2003, he gave a really good talk on how to create an API such that if you hate your users or if you actually like your users. There's 2 blog posts that he summarized it in a nice way in 2008, made it a little better. The original talk slides are really interesting. I'd recommend everybody reading it. And if you can find it, I couldn't find the link online. I think the talk was recorded somewhere, but it was from 2003. Read those blog posts. It tells you how to create an API that somebody cannot get wrong. And that's the goal. You want it to be so that your API is intuitive, is not hard to use, and is self-documenting, and all sorts of good things. Read those things. They're really good. So again, a lot of people claim that they want to move different APIs because they don't want to use them anymore, they're broken. You got to keep supporting them because you will have users. And you want to, if you do want to have people move to new things, you need to provide them guides and help and documentation for how to do that. You can't just throw a new API out there and expect them to use it. And you need to document this stuff. And you need to document it really well, because if you don't, Stack Overflow is going to try and do it. And we have so many examples in the kernel, at least. You see these common patterns get submitted to us and drivers and whatnot, and you're like, where is this wrong code coming from? And it's a Stack Overflow post that's been uploaded from 10 years ago with, here's how you solve this problem, when that's actually wrong. Downloading those and getting rid of those is impossible, so you just have to deal with that. You don't want Stack Overflow to be your primary use, your primary documentation. Provide good documentation. So in the kernel, now we have tons and tons of documentation. I don't know if anybody reads it, but we have it there to at least point people out when they get it wrong. We can say, go read this stuff. And that's the most important thing. But you need to provide a guide for how to do this type of stuff. And again, always evolve. I can't count the number of times I've seen deprecated in libraries, and you rebuild your code against a new library, and it's all of a sudden starts throwing you a bunch of warnings. That's the API, that's the library creator saying they give up. You know, that's not okay. A lot of times you can they're saying use this instead of that, then do that in the library. Work around those things, because once you have a user, you need to keep holding on to that user. I don't want to rewrite my code just because you updated something, unless there's a really, really, really good reason. And there almost never is. Please just work around it and solve the problem on your own. That being said, sometimes you do have to take a break. You do have to start over again and go on, but do that, and do that as a whole new library. GTK is a good example of they just started over, and that was great. And they different ways of doing things and different model, and you go from there. And that's a perfectly valid reason to do that. Hopefully support the old stuff because you have lots of users from that. Over time, it's nice to evolve things out of a way, but just start over. And then you have no users, and then you don't know if anybody's using your API. You don't know if you got it right until you have users, and then it's broken, and the cycle continues. That's life. That's the life of a library developer. I'm so sorry, but that's your choice. But it's very useful, very useful. But you need to, if you violate those things, you cause people to lose trust. If I see somebody, if I rebuild and see deprecated all over the place or APIs changed, then it's just horrible. You don't want to do that. You don't want to violate that trust on purpose just because you're a lazy developer, just because you feel like it could be done better, just because you want to change things. Don't do that. You're violating the trust that you're giving to a user. And if you violate that trust, you won't have that user anymore. And I've done this many times when I upgrade a library and it turns out my code that relied on it now has to change because of that. I will do everything I possibly can to rip it out and never rely on that library again. Maybe that's a good thing, maybe it's not. Usually libraries are there because I want to do something else, and a library is providing the functionality so I can do what I really want to do. I don't want to have to write the code that's in the library itself, but don't force me to. If you start breaking things, I will, and you won't have any users, and that's not okay. Please don't do that. Okay. Wow, I'm going fast. Application developers, a lot of application developers here. This is good. This isn't such a hard thing, but you guys are the most easiest to criticize, so I really feel sorry for this stuff. Everybody sees the buttons. Everybody thinks they can do something different. Everybody wants to criticize how the layout looks, what the graphics are. Look at the previous talk. Here's all these hints on how to do things better, and if you get those wrong, people get mad, and they'll get mad easily, and it's usually your core functionality of your application is somewhere else. It's not on these buttons. It's not this stuff, and people get upset. You're the easiest to criticize. It's just like a traffic engineer. Everybody knows where to put the road except you, obviously, so they will tell you about it and they will criticize you. And that's not okay. I feel very sorry for you, but here's some things you can do to do this. The biggest thing to do is don't take away things that work. If somebody's using this feature and using this functionality, keep it there. It's that simple. It was there, you provided it for somebody. Don't think by removing it, you're doing them a favor. You might be doing yourself a favor because you think it can be done a different way, but don't, because it's not going to work. And the biggest example of this, and the most public example of this, happened many, many years ago. 2011, the big date. A number of people here know what that date was. I have heard it talked by as this date, and this was the GNOME 3 introduction. Everybody's system instantly, when the distro switched it over, it looked totally and completely different. That was a major, major break. This was the day the GNOME project realized that they had real users based on the feedback they got. They always thought they had users. They always thought they were doing the right thing. They wanted to make a change. They wanted to do something different. But this was the day that they really broke all their users' trust, because all of a sudden they imposed a totally different model onto them, onto what they were currently used to doing, getting the workflow, and it broke them. It just caused a number of major, major pain. It was horrible. The LWN.net review of GNOME 3 was actually really good. It was very comprehensive, and the comments, of course, were horrible. But read these. If you're an application developer and you are considering rewriting how you do everything in a totally different way, look at this. You are seeing people mad because you took something that they were using to get their real work done. Their real work isn't to create a interface or application environment. Their real work is to do something else, and you made it harder to get them to do their real work. You broke their trust, and that was a long way. And the GNOME developers clawed back from that. It took them many, many, many years to do that. I think they're there now. I know myself, I switched away and came back many years. They've gotten better since 2011. They realized having a clean break doesn't work, and that was not the best idea. Please don't, in your application, do the same thing. I see this happen a lot. People evolve applications to do something totally different UI. That's not a good idea. Please don't do that. As a result, everybody here knows Made in Cinnamon sprung up. They fill a real need. These are real desktops that are with lots and lots of users because they were used to it before, or they're used to that common paradigm. That's fine. But this is an example that kind of shows that what the GNOME developers did was major and was really big, because there's two separate projects to fill that void. That's fine if the GNOME developers wanted to do that, they did. That was their decision to do. Again, we're writing software for free. You're throwing it over the wall. I would say that maybe that wasn't the best decision to do. But hey, maybe you should have called it a different project, gone off on a different way. That's their decision. Again, be aware of this. It will happen. But you want to change. The thing about applications and IDEs and interfaces and whatnot, you want to change based on time, based on the world. We change because we have to change, based on different ideas, how things work. So there's really two acceptable ways to change in order to keep your users. And that is, you can evolve slowly so that no one notices. That's like the kernel. We add new features, we don't take things away. We do nice things, we evolve in such a manner that everybody's like, oh, that's just a common change. I have my common paradigm from before, I can learn the new stuff and keep on going. It's a constant evolutionary change. It isn't jarring, it isn't major, it isn't a whole new paradigm and stuff. And again, the best example of this is KDE. KDE has evolved and changed over time. If you look at the old model versus the new stuff, but they've evolved in such a way that the ideas are still there. You can still have the same features. You haven't broken anybody's workflow. You added new stuff. You maybe moved things around a little bit, made it prettier. Of course, things evolve over time, but you didn't break anybody. And because of that, you don't hear anybody complaining about the new versions that much. Right? They update to a new one. They're like, hey, it looks fancier. And they keep on going because they can get their real work done. And their real work is what they want to have done. So that's a really good way. KDE does this very well. GNOME, since the big break, has done it pretty well as well, if you look at their individual releases. But again, maybe they learned from KDE. I'm glad you guys are talking. Another way you can do this is if you provide a compelling reason to make the change. You have to provide enough reason and enough goodness to force somebody to take the time to learn to do something else. That's very rare. It happens very, very rarely in application space. Sometimes in library spaces it does. I'll call out systemd as a good example of how they did it right. They provided all the functionality. They solved a real problem that was there. They unified all these existing tools and problems in such a way that it was just so much better to use, and it provided enough impetus that everybody was willing to do the work to modify their own stuff and move to the new model. It worked. People still complain about it, but it worked. Everybody switched. Everybody updated the new stuff that KDE is doing with systemd on how it launches better. It's very nice. GNOME was integrated with it from the beginning, from very early. It works well. It solves a real problem. Again, that was an example of how you can provide a compelling reason to move on and make the change. So again, never break somebody's trust. Or they will leave. If you want them to leave, that's fine. But realize they will leave if you do break that trust. And for my final rule, again, you don't want to make anybody mad. They will not be your users anymore. It's that simple. That's it. If you take anything, again, it goes back to my first slide. Don't make your users mad. And you make your users mad by throwing changes at them that they're not expecting, so they can't get their work done. And that's all. That was fast. 55 slides in half an hour. So, questions? Anything else? How do I do this? Questions in the shared notes. Okay, shared notes. Okay. Big change in your application. Do it step by step. Yes. Again, evolve over time. Libraries, just keep adding to new libraries. Applications change things over time slowly, and keep the old paradigm, the old model. If you want to switch to something major, make it a whole new program. It's that simple. Symmetric semver, signaling breaks by changing major versions. I think it's pointless. If you're going to signify a break by a major version, just call it a new library. Just make it a new name. It's that simple, because you're telling the world, throwing everything away, you got to start over again. It's no different. Just support the old one, support the new one, and move on. Yes, I can understand if you don't want to make changes and move to keep the old API around, but you threw it out there, so it's your responsibility in a way to maintain that. I don't think Semver is a good idea. It just, in reality, it doesn't work very well. Auto-contained projects in Linux world. We have the whole Flatpak, Snap, all that other stuff people are doing. There's other solutions with that. Docker containers. I mean, in a way, we have more solutions for this than anybody else has ever had for any other operating system. People are working on that problem. Or you link it all statically together. There are solutions to do this. I'm not in this area space. Talk to other people that are. I'm way below that, so I don't know too much about this stuff. Apple doesn't follow this at all. They change things all the time, just delete APIs. You don't see the same kind of upset about this. You don't see the developers. Are you kidding me? Apple's lost more developers over time than anybody else. Developers for Apple products are mad, and they don't like it. And you see them complaining all the time. They are willing to put up with it because that's their business and that's their job. They don't like it. They don't like it at all. So I think Apple's providing a disservice by doing that. Now, I know why Apple wants to do that, because it's hard to keep things around for a long time. But to say that it doesn't cause problems is naive. It does cause problems. Look, there's tons of blog posts about it and arguments about it, and how old applications don't run anymore, et cetera, et cetera. It's hard. Apple's big enough, and they throw their weight around, and they can get away with it. But they don't care about their developers as much as they care about their users. Sorry. Any kernel technology, user space devs? Yes, I/O U-ring. User space developers who care about I/O should pay attention to that. I know the Postgres developers are looking at it now. Other database developers, it is asynchronous I/O with no system call overhead. Very, very fast I/O. You can throw things into a ring, and you get notified in user space when your data is there. Very, very good if you care about I/O. I recommend looking at that. eBPF if you care about networking and networking control planes and stuff like that. And tracing and modifications of the kernel as it runs. eBPF is great. You don't have to write kernel modules anymore. You don't have to write drivers anymore. You can do some really cool stuff. eBPF just keeps getting better and better. There's an eBPF conference last week, so go look at the notes for that. There's a book now about it. It changes all the time in the kernel, but it's really, really, really good. Again, that's what's exciting in Linux development. You should pay attention to. Linux is boring. We just provide a unified way to look at all your hardware. We support all the hardware, but we do so in a boring way that for an application you shouldn't care, because it doesn't matter what hardware you run on. That being said, new system calls we provide, take advantage of those. We add a new system call every other release or so to solve some problem. Usually they don't get added to the library, to the libc quickly. You can take advantage of it on your own and use it in your application, and roll back if you don't. You can test if it's there or not. Those are good things. I've proposed a few system call recently, but I don't have any actual users for it, so it doesn't get merged. So I need an actual user for it. So that was to do read and write of small files really quickly. Or read files quickly, not writing. What happens when the change you're up to is only important for the new users? Great, we add support for new users all the time, and you want to support new things, but don't break old users. That's the trick. It's sometimes a little different, because I know there's lots of applications that have been around for forever that have really old UIs, but they keep those old UIs in an old UI model because they want to keep those old original users, because that's what made them successful. And you can switch and add new properties and new things for new users as well. It's hard. I'm not saying it's easy to do. But this is why you're writing application software and not kernel software, right? Because you like doing this type of stuff. Just at least be nice to your users. What's the best way for our developers to stay up to date on kernel tech? Linux Weekly News, lwn.net. You can subscribe to it. They're a great organization, or you can just wait 2 weeks and the articles come out after that. If you're 2 weeks behind on latest kernel development, you're perfectly fine. So I recommend doing that. That's the best way. That's how we all get know things, what are going on. We all read it as well. I think I answered all the questions. Anything else?
Oh man, what a talk was it? What it was. Thank you so much, sir, for the great talk. I'm sure
Okay,
that this
I got to
talk.
answer this last question. The color
Okay,
coded
there is a
books.
question.
During the first Corona breakdown, I live in Europe, or lockdown, my daughter had to come home for university, and I'm in the little library. She color coordinated the books to be for her conference calls, for her university talks. I didn't color coordinate the books. She did that, so it was very Instagrammable. I take advantage. I give her full credit for that effort. It makes a pretty background. Sorry. Okay.